All right. Our first thing we're going to look at is, our essential question is, how do I calculate horizontal and vertical, a little off the screen there. How do I calculate horizontal and vertical? I'm going to put this in big capital letters. Change between points. Let's call our topic, our general topic is coordinate plane. Up until now, we've talked about horizontal and vertical distance between points. Horizontal and vertical distance. That's just how far apart things are. Change has a little bit of extra information in it. It actually turns out it's slightly less complicated to calculate. Change involves not just how far apart things are, but what direction. So we move from one place to the next. So, change is a little bit different than distance. So, let's take a look at a couple of points here. I'm just going to put example. Pick a couple of random points. How about 3, 7 to 5, -3. From 3, 7 to 5, -3. I put the arrow in there. We are traveling from the point 3, 7 to the point 5, -3. Because it's important what direction we're going. Let's just make a real rough sketch of what that looks like. There's our coordinate plane. The point 3, 7 is up here somewhere. And the point 5, -3, let's forward a little bit and kind of down here. And we are traveling in that direction. Just as a kind of side note to let you know why we're doing this. I've asked you to calculate areas of some shapes in the coordinate plane. And those shapes, for example, we did some rectangles. And the area for a rectangle is just base times height, which is simply one side times its adjacent side, two sides next to each other. Well, that only works with rectangles. So it only works with a shape that has 4 sides and 4 right angles. You can't use that same sort of method or formula with a shape that does not have 4 right angles. So we need to know, if we're looking at a shape in the coordinate plane, does it have 4 right angles or not? So as we're traveling along, if I'm traveling in this direction and I take a turn, am I taking a turn that's a right angle or not? We're going to be able to use this horizontal and vertical change calculation in order to determine whether or not the turns we take in the coordinate plane are turns at right angles. All right. Let's scooch this down a little bit. First of all, our horizontal change. Which has a name. It's called delta x. And this little symbol here is pronounced delta. It's a Greek letter. All right. It is used in mathematics to represent things that change or small amounts of change. So we're looking at a change in your horizontal position. It's called delta x because we measure it according to our change in our x coordinate. Horizontal change is ending x minus beginning x. A lot of times when we see formulas, we might see x1 minus x2, or xb minus xa. And then there's always confusion about whether or not, which point's 1, which point's 2, which point is A or B. Does it matter? The point here is that if we're calculating change, it's always the ending location minus the beginning location. End minus beginning. So all that matters is what direction are you going? Where are you starting? Where are you ending? End minus beginning. So here, our delta x equals our ending x coordinate is 5 minus our beginning x coordinate, which is 3, and our change is 2. If you look at it here in our little rough graph, we've moved from an x coordinate of 3 to an x coordinate of 5. We've moved 2 spaces forward. And just to toss this out too, I have talked with this is a common misconception. I try and find ways to approach it or confront it, but I'll just tell you straight up. One misconception a lot of people have is that when we move from one point to another, so I talk a lot about forward movement, vertical movement, horizontal movement. A lot of people get the idea that what I'm talking about is actually moving from this location here forward and then down. And I'm not talking about that. I'm talking about starting here and traveling straight down to this point here, but by the time you get there, you're forward from where you started. You're also down from where you started. So it's not that we're actually traveling this sort of, the 2 legs of the right triangle. It's just that the legs of the right triangle are ways that we measure how far forward, how far up or down we are. Okay, so that's our horizontal change. And this translates into 2 spaces forward. 2 spaces forward. We know it's forward because it's positive. Positive 2 means 2 spaces forward. All right. I'm actually going to flip my paper over simply because we'll do our change in y on the back because we don't have room down here. So you can turn the page over. Next we have vertical change. Real similar to horizontal change. We call it delta y. Again, the little triangle symbol, it's a Greek letter. The Greek letter is delta, and it's used in mathematics to represent change. Vertical change is calculated as ending y minus beginning y. So where your y coordinate ended up minus where your y coordinate started. So in this case, I'll flip back to our points here again. We look, we started at a y coordinate of 7. We ended at a y coordinate of -3. So it's going to be -3 minus 7. Go back and take a look. Our delta y equals -3. I'm just putting it in parentheses to remind myself of the negative there. Minus +7. If it's 3 degrees below 0, the temperature drops another 7 degrees. It's now -10. And this we interpret as 10 spaces down. Yeah. This is the next thing I was going to talk about. So before, when we were calculating the distance between the points, in this case, the vertical distance between the points is positive 10 spaces because we never talk about distance as being negative. But here, we're not talking about distance, we're talking about distance and direction. So going back to our picture here, the horizontal distance between the 2 points is 10 spaces. Or I'm sorry, vertical distance between the points is 10 spaces. But if you include the direction we went, we moved from 3, 7 down to 5, negative 3. If we include the direction, it's a negative 10. Our total movement, our change, was negative 10. So the only difference between calculating change and calculating distance is we leave off the absolute value part. Otherwise, it's the same calculation. But we have to be careful because when we were doing just distance, it didn't matter which point we started with. Now it matters. You have to do end minus beginning for both calculations. If you do it the other way around, you might get mixed up, and you would think of it, if we're going the other direction, it would be a movement that's back 2 and up 10. There's a difference between back 2 and up 10 and forward 2 and down 10. All right, so let's get this worksheet out. I'll show you what I want you to do on this. This isn't too difficult. All right. Okay. What we're finding here is the amount of vertical change per unit of horizontal change. So to do that, all we have to do is calculate horizontal and vertical change and then divide. And if you, I'll show you. It's not hard. Okay. So let's start with delta x. And in this case, for all these points, we're traveling from the first point to the second point in every case. Okay. So our delta x will be end minus beginning, 14 minus 5 equals 9. So that's 9 movements, 9 units of movement to the right, forward, positive. Next we have our delta y, our change in y. And remember, it's ending y minus our beginning y. So be careful here. It's 5 minus negative 5. So remember, if you subtract a negative, it's the same as adding a positive. So 5 minus negative 5 is the same as 5 plus 5, or 10. You think about it, if I were to graph this, we've moved from a y-coordinate of negative 5 up to a y-coordinate of positive 5, positive 10. So our horizontal change is 9 spaces forward. Our vertical change is 10 spaces up. And to calculate the horizontal change or vertical change per unit of horizontal change, we just divide delta y divided by delta x. So we have 10 divided by 9. Which we could, turn into a decimal, but we don't really need to. Let's do one more. Next door here, our delta x is our ending x coordinate, negative 5, minus our beginning x coordinate, which is 11. If the temperature is 5 below 0, we drop another 11 degrees. We're at negative 16. And this means that we've moved backwards or to the left 16 spaces. Our delta y is 13. We ended at 13. And then we moved it does say negative 13, sir. No. I said hold on. All right. So we got 13 minus our beginning y coordinate, which was 8. 13 minus 8 is 5. That means we've moved 5 spaces up. And then to calculate our vertical change per unit of horizontal change, we just go, we divide our change in y by our change in x. And so we get 5 over negative 16, which we could turn into a decimal, but we're not really going to worry about that. By the way, if it does come up, a couple little things here. Typically, we don't leave a negative sign down in the denominator, so we would just put the negative sign out front, like so. Another thing is, you may come across cases where you could reduce the fraction. And if you can reduce the fraction, reduce it. Okay. All right.